Common prefix used in SI units. Prefix is used to indicate decimal fractions of multiples of various units by powers of 10 or refers to a word added before a base term to modify its meaning. To memorize common prefix used the following tricks. The great mighty King Henry died by drinking chocolate milk until non-promptly. T stands from Terra, symbolized by T and 10 the power of 12. G stands for Giga and it is denoted by G, 10 the power of 9. M stands from Mega, denoted by M, 10 the power of 6. K stands from Kilo, it's denoted by K, 10 the power of 3. H stands from Hecto, H denoted by H, 10 the power of 2. D stands for Deca and it is equals to or equivalent to 10 the power of 1. D is Deci, denoted by the small letter D, 10 the power of minus 1. Centi, C stands from C, centi, denoted by C, 10 the power of minus 2. M stands from milli and denoted by M times 10 the power of minus 3. M is micro, 10 the power. N nano, 10 the power of minus 9. M micro, 10 the power of minus 6. P pico, 10 the power of minus 12. The second point is dimensional analysis or factor level method. Is the method of calculation in which one carries along the units for quantities or refers to converting a measurement from one unit to another by using a conversion factor. Consider the following 4 points before changing one unit to another unit. The first, if you want to convert from small to large. Point 1, take ratio of units, small unit divided by large unit is equals to conversion factor. Then the smaller unit multiplied by conversion factor, then you get the required result. The second point, take ratio large unit divided by small unit, you can get conversion factor. Then the smaller unit divided by conversion factor to get the required result. If you want to convert from large to small units, the third point, take ratio small unit divided by large unit, then you can get conversion factor. The larger unit divided by conversion factor to get the desired result. The fourth point is take ratio large unit divided by small unit is equals to conversion factor. This conversion factor multiplied by the large unit, then you can get the desired or required result. For a better understanding, see the following examples. Example 1. Convert 5 microgram to nanogram. First case, take the ratio for SI units. These are microgram divided by nanogram. Gram cancelled by gram. From the prefix, micro means 10 to the power of minus 6 and nano means 10 to the power of minus 9, then is equals to 10 to the power of 3. We convert large unit to a small unit. Then the ratio for the units, large unit divided by a small unit. Then the required result is equals to the conversion factor times the given result. 5 times 10 to the power of 3, we can get 5000. Then 5 microgram means 5000 nanogram. The second question, a certain person is 160 centimeter tall. Express this height is A in millimeter, B in micrometer. Then take it. The ratio centimeter divided by millimeter, meter cancelled by meter, then we can get centi divided by milli. We know the prefix centi means 10 to the power of minus 2 and milli is 10 to the power of minus 3. The ratio result is 10 to the power of 1. The unit is large to small. Then large divided by a small units. We can get the conversion factor 10. 168 times 10 is equals to 1680 millimeter. The second question B changes to micrometer. The same process. We convert or change the ratio of the unit. Small unit divided by large unit. Micrometer divided by centimeter. Then we can get 10 to the power of minus 6 divided by 10 to the power of minus 2. The conversion factor is 10 to the power of minus 4. if you want to convert large unit to small unit and the ratio is small unit divided by large unit, the required result is equals to the larger unit or the larger unit divided by the conversion factor is equals to 168 divided by 10 to the power of minus 4 is equals to 168 times 10 to the power of 4 or 1.68 times 10 to the power of 6 micrometer. The third question, what is the fraction of a second in a picosecond? Second converts to picosecond. Let's take the ratio of each unit, second divided by picosecond. Second cancelled by second. Then the remaining one is 1 over pico. Pico means 10 to the power of minus 12. 1 over 10 to the power of minus 12 is equals to 10 to the power of 12. We can get this conversion factor. We want to convert larger unit to small unit. And we take what? We take the ratio larger unit divided by the small unit. If we want to convert larger unit to small unit, then take the ratio larger to small unit. You multiply the given result by conversion factor and get what? The desired results. 1 times 10 to the power of 12 is equals to 10 to the power of 12 picosecond. Then a second is congruous to what? 10 to the power of 12 picosecond. The third point for this presentation is uncertainty and measurement. Measurement is the process of determining the quantity or amount of a substance by using a standard, known standard or scale. In chemistry, measurements are essential for experiments, calculations, and understanding chemical properties like balance, volumetric flask, pipette, thermometer, spectrometer are used for measurements. From this, first we define one uncertainty mean. Uncertainty refers to the doubt that exists about the result of any measurement. There are different causes for occurring uncertainty. The first one is limitation of the measuring instrument. Maybe the measuring instrument highly sensitive or lower sensitive. This influences the results or the uncertainty of the measurement. The skill of the person performing the measurement. A skillful person measures more accurate, but the less skillful person measures low accurate measurement and low precision measurement. The third one is environmental conditions like temperature, humidity, pressure affect the measurement. The other one is random variation. To minimize uncertainty, do the following points. The first, calibration instruments regularly. Calibration is the process of comparing instruments against known more accurate reference standard to determine this accurate and correct any deviations. It's like checking a ruler against a master ruler certified by a national standards law. The second one is use appropriate techniques to train operators and other methods. The third one is replicate measurements or average results to reduce random errors. The fourth point, use high quality reagents and standards because expired reagents and chemicals affect the measurement. The other one is control environmental conditions, especially for random error. The cause is also unknown. For better understanding uncertainty, see the precision, accuracy, random error, and systematic error mean. First, we see precision. Precision is how close repeated measurements of the same quantity are to each other. Consider the following two measurements. The first measurements are 9.1, 9.2, 9.3. The second one is 10.5, 12, and 11.8. Precision can be determined by range or standard deviation. Range is high, low precise measurement, and range is low, high precise measurement. Then range is equals to the highest or the largest measurement minus the smallest measurement. The first measurement, the smallest number is 9.1 and the greatest number is 9.3. Take the difference. 9.3 minus 9.1 is 0.2. It is what? Range is 0.2. The second measurement, the highest is 12 and the smallest is 10.5. Take the difference of the two, 1.5. We have two ranges, 0.2 and 1.5. 0.2 is smaller than 1.5. Then 0.2 is what? High precise measurement. The first measurement is high precise measurement, while the second measurement is low precise measurement. The second point is accuracy. How close individual measurements with the true or expected value. Consider the following two measurements. Suppose the true concentration of solution is 10 molar. The two measurements are, the first one is 10.1, 9.9, 10, and the second measurement is 11, 9.0, and 12. Accuracy can be expressed by relative error and percentage error. Error is equals to absolute value of true value minus the average value of the measurement. If error is a small, more accurate measurement we have, and error is large, less accurate measurement we have. For calculating average value, first define it. Average value is the sum of individual measurements divided by the total number. Total number for the given results is 3. The first measurement can be calculated. The average value is equals to 10.1 plus 9.9 plus 10 divided by 3. We can get 10. Calculate first error. Error is equals to the true value is 10 minus the average value is 10 is equals to 0. The second measurement is 11.0 plus 9.0 plus 12.0 divided by 3. To get what? To get the average result. Then the average result is equals to 10.6. Then calculate the error. Error is equals to the true value 10 minus the average value 10.67. Absolute value 8. We can get 0.67. Compare the two. The first error is 0 and the second error is 0.67. Lower error means high accuracy. The first measurement is high accurate measurement, while the second one is high error, so they are low accurate measurement. Let's see systematic error. Systematic error is produced bias or accuracy, cause all results to be affected in one sense only, all too high or all too low from the true value. Let's take specific example. True value is 11 centimeter. We have 4 trials. T1 is 10.99, T2 is 10.98, T3 is 10.97, T4 is 10.96. We compare from the true value. True value is 11 centimeter. The 4 all results lower than the true value. So there is a systematical deviation. All the trials lower than the true value. So this measurement has a systematic error. Systematic error cannot be detected simply by using individual replicate measurements caused by faulty calibration and incorrect techniques. Can be corrected by using proper calibration and uses correct techniques. The other error known as random error. Random error affects precision, cause replicate individual results to fall on either side of average value. We take average value, not a true value. Consider the following measurement: 10.1, 9.9, and 10. We calculate the average value by summing and divided by total number. The sum and divided by total number is 10, means the average is 10. This average value is comparing within the individual measurements. This average value, sum of lower than, sum of greater than, and sum are equal within the average value. Either mean value, the individual measurements fall, then there is a random error. 10 is lower than 10.1 or 10 is greater than 9.9. So this measurement contain what? Random error. Can be minimized by good techniques but not eliminated. There are different causes: uncontrollable, unpredictable fluctuations like instruments, noise, electrical, thermal, and so on. Human limitations in reading skills, environmental fluctuations, vibrations, inherent sample variability are the causes of random variations or random error. To understand precision, accuracy, systematic error, and random error, use the following examples. Imagine measuring the length of a meter rod whose true length is 100 millimeter. Measurements, there are 4 measurements or 4 persons measure this metal. The first one is 99.9, 100, 100.1. The average result of this is 100 and the error can be 0 and range is 0.2. The second measurement is 98.5, 101, 100.5. Average result is 100, error is 0 and range is 2. The third one is 102.1, 102.0, 102.2. Average result is 102.1, error is 2.1 and range is 0.1. The fourth measurement is 101, 103 and 100.2. Average is 101.4, error is 1.4 and range is 2.8. From these, 1 and 3 are more precise measurement because they have what? The smaller 1 and 3 more precise. They have the smaller range related to the other. 2 and 4 are less precise because they have greater range. 3 and 4 are less accurate because they have greater error. 1 and 2 are more accurate because the error can be 0. 1, 2, 3, 4 have random error because all measurements have random error. 3 and 4 have systematic error because they deviate systematically. The other point is decimal place. Decimal place refers to the number of digits to the right of the decimal point. Decimal point is used to separate the whole number part from the fractional part of a number. Let's see 0.087. Decimal point for the left side are known as whole number. The number found from the right side of decimal point, we call it decimal places. Understand decimal places used for round off. Round off means finding a number that is closer to a given number, but with fewer digits. Decimal places, let's see. First decimal place means tens or 10 to the power of minus 1. Second decimal place means hundreds, 10 to the power of minus 2. Third decimal place means thousands, 10 to the power of minus 3. Fourth decimal place is 10,000s, 10 to the power of minus 4. Fifth decimal places 100,000s, 10 to the power of minus 5, and so on. Let's see 12.345. 3 is tens, 0.4 is hundreds, and 0.5 is what? Thousands. Rules for rounding off. 1. If the digit to be removed is less than 5, the preceding digit is retained. Round 10.13444379 only into decimal places. First, identify 2 decimal places. The first decimal place contains 1. The second decimal contains 3. The remaining digit is 4. So 4 is below 5 and the result becomes 10.13 because the removing digit is lower than 5. The other example is round 369.641 only in one decimal place become 369.6 because the removing digit is 4. 4 is lower than 5. The other rule related to decimal places or rounding off. If the digit to be removed is greater than 5, then we have to add 1 to the preceding digit. Round 936.758 only in 2 decimal places. First, identify 2 decimal places. The 2 decimal places are 0.75. After 5, we call it a removing digit. A removing digit is 8. So 8 is greater than 5. The preceding digit is 5. 5, we add 1 from 5. The result becomes 936.76. The other example, around 3.1269 in 3 decimal places. 3 decimal places means 0.126. The remaining is 9. 9 is what? A removing digit. So 9 is greater than 5. The result becomes 3.127. The third point is if the digit to be removed is 5, the preceding number increases by 1 if it is odd. Round 18.75 in one decimal place. Means 0.7 is one decimal place. The other 5 is what? Removing digit. Before removing digits, it is 7. 7 is odd. Odd number increased by 1 or add by 1. Then the result become what? 18.8. The other round 8.135 into decimal places, which become 8.14 because 3 is what? Odd. Then after odd, we can get 5. 5 is a removing digit. The 3 number is increased by 1. The fourth rule, if the digit to be removed is 5, the preceding number remains unchanged if it is even. Round 20.65 in one decimal place, which become 20.6 because one decimal place means 0.6. After 6 we can get 5. Before 5 we have what? Even number 6. 6 cannot be changed or altered. Around 17.3485 in 3 decimal places. 3 decimal place means 0.348 and the removed digit is 5. Before 5 there is even number. The even number cannot be affected by 5. The result can be 17.348. Let's see the other point, significant figure. What is significant figure mean? All digits known with certainty plus one of uncertain value are called significant figure. 1.31 we say all numbers are what? Known. 1 known, 3 known, 1 known. After 1 there is what? Unknown or uncertain number. The combination of the two numbers we call it what? Significant figure. The following guidelines apply to determining the number of significant figures. 1. If the zeros precede the first non-zero digit, they are non-significant. Let's take specific example. 0.00008. All zeros found in what? Before the non-zero digits. Then the zeros precede non-zero digit, so these zeros are no significant figure. The only significant figure is 1. It has only one significant figure. The second rule, if the zeros are between non-zero digits, they are significant. Let's take specific example. 1.00008. Zeros found between what? Non-zero digits. All are significant figure. This number has 6 significant figures. The third rule, if the zeros follows non-zero digits, there is ambiguity if no decimal points is given. Let's take 5,000 without decimal place and 500.0. The first 5,000 there is no decimal point, then the significant figure is ambiguous. While 500.0 there is significant figure and there it has decimal point, so it has 4 significant figure. The other rule, non-zero digits are always significant. Let's take 683. It has 3 significant figures. 6,834. It has 4 significant figures. Operations of significant figure. Addition and subtraction. When we add or subtract the decimal places or significant figure, the result should be the same as the smallest decimal place in the given data. Let's take 2 specific examples. 200.1 plus 1.21 plus 0.02246. The result can be 209.33246, but it's not the final answer. But the smallest decimal place from the given is 1, then the result round off into one decimal place. 209.3 is the first decimal place. After 3 we can get 3. 3 is lower than 5, then it rounds to 209.3. The second question related to this, 4.05 minus 0.125. We can get 3.925, but it rounds to 3.92 because the smallest decimal place from the given data is 2. The other is multiplication and division. When we multiply or divide number, the result should be the same as the smallest significant figure in the given data. 1.78 times 1.03 divided by 1.3. The result can be 1.410, but the lowest decimal place, the lowest significant figure is 2. During multiplication, at the division, significant figure, lowest significant figure always equals to or similar to the result of the significant figure. Then this result round into two significant figures. The result can be 1.4. The other point is scientific notation. Is a way to express extreme large or small number compactly using powers of 10. Represented by a times 10 to the power of n. A can be 1 up to 9, but not 0 and 10. N can be positive, negative, or 0. N can be positive for large number. Move the decimal left until one digit remains before the decimal. Let's take a specific example, 12,400. This is what? 1.2400 times 10 to the power of 4. Moves 4 places to the left. 6,500,000. 6,500,000. 6.5 times 10 to the power of 6. Moved 6 places left. N can be negative for a small number. Move the decimal right until non-zero digits obtained. 0.00076. 7.6 times 10 to the power of minus 4. Moved 4 places to the right side. 0.0000000A01 is equals to 8.01 times 10 to the power of minus 8. Moved 8 places right. This scientific notation used for what? More compactness, easier to understand, simpler to manipulate. Calculation in scientific notation. For multiplication, a times 10 to the power of m times b times 10 to the power of n. We take what? It is equals to a times b times what? 10 to the power of m plus n. For division, a times 10 to the power of m over b times 10 to the power of n. It is equals to a over b times 10 to the power of m minus n. Addition or subtraction, exponent or power must be the same. Then a times 10 to the power of n plus or minus b times 10 to the power of m. If m is equals to n, we call it x, a plus b, the whole times 10 to the power of x. The other point, chemistry as experimental science, especially scientific method we take, is a scientific approach to research involving observing, hypothesis formation, experimentation, and conclusion are the steps for scientific method. The first one is observation, identifying a problem. Notice problem in the natural world and ask a question. What is happening? Why does this occur? Let's take a specific example. Plants placed near a window grow faster than those in a dark room. The second, prepare hypothesis or propose testable explanation. Develop a tentative explanation for the observation. If plants receive more sunlight than their growth rate increases. If plants receive more sunlight, then their growth rate increases. It is hypothesis, but this hypothesis can be what? Checked, proved or disproved by experiment. The third point is experimentation. Test the hypothesis. Conduct controlled experiment to prove or disprove the hypothesis. Let's take variable, independent variable manipulated, that is sunlight. Dependent variable measured, plant site. We measure the plant site found from the dark side and outside. The other is controlled variable, held constant, example water, soil type with the same amount of water both places, with add the same types of soil in both places. Control group baseline for comparison of plants with no sunlight. Repeatability, trials must be received to confirm results. The other point, it is conclusion, analyze the result. Analyze data using statistics, graphics, determine if results support or reject the hypothesis. The other points from this, we take what? Laboratory safety rule in chemistry. The first one is responsible behavior. No reckless actions, example running horseplay. Spilled chemicals or broken glass pose severe risks. The second point is eye protection. Wear approved safety goggles at all times in labs, chemical storage areas. No unauthorized experiments. Follow instruction exactly. Quantities or procedures. Consult your teacher if uncertain about any step. The fourth is no smoking. Smoking is a fire hazard. Chemicals in lab, air, vapor, dust can be inhaled. The fifth is fire accident response. Call the teachers immediately. Note locations of fire extinguisher, emergency shower, eye wash stations, first aid kits, fire blankets. Now this location. The sixth point is chemical handling. Never test or sniff chemicals directly. Use fume hoods for volatile or toxic substances. The seventh point is waste disposal. Dispose of chemicals, glassware as instructed or never in sinks unless approved. 8. Glassware safety. Check for cracks before use. Never force glass tubing into stoppers. Lubricate first. 9 point. Clothing and hygiene. Tie back long hair. Avoid loose clothing jewelry. Wear closed-toe shoes and lab coats. Wash hands after handling chemicals. The 10th point for safety, clean workspace. Keep benches clutter-free. Clean spills immediately. Follow protocols and for acids or bases. Why to do this? To prevent injuries, to ensure accuracy, to build discipline. Last point for this presentation is laboratory apparatus. On the basis of their use, this apparatus can be broadly classified into 3 categories. These are reaction bases, measuring equipment, support and heating devices. The first one is reaction vessel. Containers for holding, mixing or reacting chemicals like test tube, beaker, Rimler flask, round bottom flask, reagent bottle, crucible petri dish used for reaction vessel. The other point is measuring equipment. Instruments for quantifying volume, mass or other properties like graduated cylinder, burette, pipette, volumetric flask, analytical balance, thermometer, pH meter. The third one is support and heating devices. Equipment for holding, positioning or applying heat like ring stand, tripod stand, Bunsen burner, hot plate clamps, retort stands, wire gauze, clay triangle, condenser. Such types of material is used for laboratory purpose.